Hello everyone, this is Tushar. So my project is implementation of advanced encryption standard on FPGAs. FPGA is something field programmable gate array. So that is a kind of chip that can be programmed, and that chip has gates, different kind of gates are like AND gate, OR gate, NOR gate, like that, and array. So it has array of those gates which can be programmed. So this chip we can program as per our requirement, whatever kind of requirement we have. So in my case I will be implementing AES algorithm, and that's why I will be writing code for it, right? So we going to review that code today that I have written. So let's start with Model Sim. So this is a software called Model Sim that is from Altera. Altera is a company. So here we can see this work. Under work folder I have different files that I have created. So first I would like to talk about this small part of the algorithm, which is substitution box. These two files, sbox and sbox4. Here I can show okay, yeah, so this is a schematic. So here we have this portion sbox, and under sbox4 I have instantiated 4 sbox, this 1, 2, 3 and 4. So let's see what we have in this file sbox. So let me open. Box. Okay, so this code here is written in VHDL language, that is hardware descriptive language. We can see .vhd here, the extension .vhd, that is hardware descriptive language, VHDL. There could be different languages for hardware descriptive language, like Verilog is also one of the language, but all these files are written in VHDL. So since this is the first file we are looking at, let me just go through the syntax of VHDL file. So first of all we need to add some libraries that are needed. Then we have entity. So entity is something we are defining, kind of chip we can say, and the name of entity. Here it is sbox, right? Then we have ports are like input and output. We can think of any chip that has different pins, right? Some of the pins are input and some pins could be output, like that. So this is a name of pin, sbox in, sbox out, like we assigning some name to the variable, same. And this is a type, standard logic vector. That is a type, like in Java and C we have like integer, float, like that. And that is 7 down to 0, meaning starting from 0 to 7. So it has total 8 bits. This is standard logic vector. It represent a kind of array. So This is 7 down to 0, which is 8 bits. Same way we have this output, and that is also 8 bits, 7 down to 0. Then we have the architecture. This is a syntax, typical syntax of hardware descriptive language. So in architecture, this is a name of architecture, which is behavior of SBox, that is again the entity name. Is, then we can write some signals. Signals are nothing but we can think of variable. Here the variable name is output. Standard logic vector, again 7 down to 0. Output, that is a variable which has 8 bits. That's how we can think of. Then under begin, like this architecture, once we have defined all the different signals, we begin the architecture. So that's why we have the keyword begin. This is the assignment of signal. So this is a signal. On right hand side it's a signal. As we can see, output is a signal that is being assigned to SBox out, that is the output port here, output port. So the value of output is being assigned to the port, that the port SBox out, right? And this is a case statement. This is a process. First off, this is a process, and this process has the SBox in as a sensitivity list. So whenever there is a change in SBox in, that is an input. If the value of input is changed, then this process will run. This whole process will run. This process will execute, in other words. So this is a sensitivity list. Whatever we have in sensitivity list, either of them, if the value of either of them changes, that's when it executes the process. So begin, this begin is for the process. Then we have case, like we have in like Python or C or Java, like same way. So if the SBox in value is 0 0, right, here X represent hexadecimal. So as we know, hexadecimal, one bit of hexadecimal has 4 bit, one hexa has 4 bit binary, right? So here, since we have 2 of them, right, 0 and 0, so we have total 8 bits. That's why we have input and output that are defined as 8 bits, right? And whenever the input is 0 0, the output value would be 63. Whenever it's 0 1, the output value is 7C. Why is it so? Let me show you the table here. This is a fixed table for substitution, SBox substitution, right? So this is a fixed table that is defined in algorithm. So that's why I have created this file specifically for this table, so that whenever we have an input like X and Y, right, 4 bits of X and 4 bits of Y, and that's how we suppose we have 5C, then the output will be 4A, like this, 5 here and C this one, so 4A. That is how we got the output. and that output we get on sbox out, which is an output of this sbox, right? And here we can see in schematic I have instantiated 4 sboxes, 1 2 3 4. Since we have 32 bit of input, that is being divided in 8 bits each, right? So that's why we have 4 sbox, and I have created a separate file for 4 sbox. Let me show that. Let me open sbox 4. So this is sbox 4. Again, this is entity sbox 4. These are the port, input port, output port, sbox 4 in, sbox 4 out. Here, as I said, we have 32 bit of input, right, and 32 bit of output. So here we have 31 down to 0, 31 down to 0. That's why we have 32 bits total. Now here in architecture this is a component. So basically this component sbox is nothing but this one, entity sbox. It is the same. So in other words, we have called a file or the entity in another file, like we do in C and Java and all that, right? Like we use a function from different file, same way here. Then then we have port map. So since we have already imported this sbox, right, then we need to assign the port, the value to, like, first 8 bit to this sbox, second 8 bits to second one, third 8 bits to the third one, and fourth to fourth, right? So that is being done here. This is a for loop. For I in 3 down to 0, generate sbox port mapping. So this I, value of I, we can substitute here, right? So it will like, if we put 3 here, right, then we will be having 31 to 24, right? Then if we put 2 here, then probably 23 down to 16, and so on, right? So this is how we create 4 different sbox. Yeah, so this was all about this 2 file, and in next video I will be talking about this top keygen is a file for key generation, and this is algoround, which has the actual algorithm. Yeah, so thank you for watching the video. We'll see you on the next video.